hearing on the Gulf of Mexico oil spill and seafood safety, chaired by Representative Edward Markey. Earlier this week, a University of Georgia report refuted the government's findings that 3/4 of the oil had been cleaned up. This is about 3.5 hours.
Welcome to the Subcommittee on Energy and Environment. For anyone who has been diagnosed with a life-threatening illness, one of the best words you can hear is remission, whether it's cancer, HIV, or some other illness. A battery of modern cures can reduce the disease to lower, perhaps even to undetectable levels. Yet even in remission, there is often unease that the disease could return, and the pestering, inevitable scientific and metaphysical questions arise: where did it go? Could it come back? Right now, we are in a similar state in this environmental disaster. After many trials and several false starts, BP finally created a system to cap and seal the well. Oil has not come from the Macondo well for about a month. We are no longer at the bleeding stage. A tourniquet has been applied to the well. And now, we are told, we may need to wait for the final procedure, the relief well, until September. And so, just like a patient in remission, we have reached a more stable stage of health with this spill. To say the well is capped is tantamount to a cure would be false confidence. Like unseen internal bleeding in a trauma patient, the veiled oil persisting in the Gulf poses continued risks. Today, we are here to ask the same questions about this spill as a patient or a doctor would of a disease. Where did it go, and could it come back? According to the most recent estimates, 4.9 million barrels of oil spewed from BP's well over the course of this 100-day gusher. Of that oil, some was captured, some was dispersed, and some evaporated or naturally dispersed. Yet, at least 1.3 million barrels still remain unaccounted for in the waters and marshes of the Gulf, an amount 5 times larger than was spilled during the entire Exxon Valdez disaster. Just as we are worried about rogue weapons sold on the black market harming the public, we must be vigilant about rogue oil from this disaster harming the public, putting a black mark on Gulf seafood or Gulf tourism. In addition to all the oil, millions of gallons of dispersant chemicals have been used in unprecedented ways. Just a few weeks ago, FDA told me that they had determined that dispersants have a low potential to accumulate in seafood and do not pose a significant public health risk through human consumption. While this news is welcome, it addresses only the issue of short-term toxicity. The FDA knows little about the long-term impacts that these compounds will have on marine life. Nor do they know how the presence of oil and dispersants may influence the concentration of other toxic compounds in seafood species. We have yet to see the full picture of hazards posed by this spill. The work done by the FDA, NOAA, and EPA will be critical in ensuring that fish and shellfish from the Gulf is safe to eat for years to come. And so we will ask today, where do we go from here? Where should monitoring and cleanup efforts be focused in this new chapter of recovery and restoration? Are the clouds of oil suspended below the ocean surface still a concern? What about the plumes of methane gas? Where have these plumes gone, and will microbes consuming methane use up oxygen in the water, potentially asphyxiating areas of the Gulf? What impact will all the oil, methane, and chemical dispersants have on marine life in the Gulf and on Gulf seafood supply in the years ahead? Is seafood from the Gulf safe to eat today? Will it be safe to eat in the future? American families want the only oil in their seafood to be cooking oil. Ending BP's gusher in the Gulf does not by itself cure the harm that has been done. The treatment of the region from this disaster has only just begun. To have a successful, continued response to this spill, we need to do three things going forward. One, monitor the health of the waters, wetlands, wildlife, and people of the Gulf. Two, maintain the pressure on BP and others to continue the recovery and restoration process. And three, muster the attention of our entire country on solving the economic and environmental challenges from our continued dependence on oil, especially foreign oil. We have an extremely distinguished group of witnesses appearing before us today. We appreciate the fact that it is the middle of the summer. We know that many people have gone away. However, the oil has not gone away, and it is important for the Gulf of Mexico residents to know that the attention on this issue has not gone away. That is why we are having this hearing today. So let us turn to our first witness, Dr. Bill LEHR. He is a senior scientist in the Emergency Response Division of NOAA, where he leads the spill response group. He has been active in spill research and response for more than 15 years. We thank you, Dr. LEHR, for being here. Whenever you feel comfortable, please begin.
Thank you, Chairman Markey and members of the subcommittee for this.
Could you turn on your microphone?
It should be on.
Okay, and move it, then
there we go.
A little bit closer.
Thank you.
Thank you.
Thank you again, Chairman Markey and members of the subcommittee for the opportunity to testify here for the National Oceanic and Atmospheric Administration's role in the recent Deepwater Horizon oil spill response. I would like to discuss the critical roles that NOAA serves during oil spills and their importance to their contributions to protect and restore natural resources, communities, and economies affected by this recent terrible event in the Gulf of Mexico. NOAA's scientific experts have been assisting with response from the first day.
Could you lower your microphone a little bit? Just
okay.
Good. Thank you. That'd be better. Yes.
Normally, I'm so loud that people don't even put me on a microphone, both on scene and through our headquarters and regional offices. NOAA's support has included daily trajectories of the spilled oil, weather data for short and long-term forecasts, special forecasts for cleanup operations such as the in-situ burning. NOAA experts analyzed the satellite imagery and also performed real-time observations to help verify the spill location and movement. In addition, NOAA scientists are providing expertise and assistance regarding sea turtles, marine mammals, and other protected resources such as corals. NOAA is also coordinating with the federal and states, co-trustees, and responsible parties to conduct a natural resource damage assessment, which is a process that quantifies the total losses and develops restoration projects that compensate the public for their losses. NOAA has also participated in a number of interagency expert teams. These include the flow rate technical group that estimated the size of the spill that you referred to, and also a joint effort with NOAA, the Department of Interior, the Coast Guard, the National Institute of Standards and Technology, and other outside experts to develop an oil budget calculator to estimate, for response purposes, the fate of the spilled oil. Now, there's been a lot of discussion on this budget, so let me get into a little details on it. Basically, according to what our experts were able to determine, the oil that was spilled could be divided up into 4 basic categories. About 1/4 of it was either recovered directly, was burned in situ, or was skimmed on the surface. Another 1/4 either evaporated or dissolved into the water column. And another 1/4, as you mentioned before, several times the size of the Exxon Valdez, remains out there for cleanup purposes. And then another 1/4 was dispersed into the water column. Now, part of that was through natural dispersion, other was through the use of dispersants. Dispersants for the Deepwater Horizon spill were only used where oil was present on the surface, or they were applied at the wellhead on the sea floor. A total of 1.8 million gallons of dispersants were used. These the effects of the dispersants are being monitored by NOAA. Also, the dispersed oil, there are over 2,000 water samples have been collected in the deep waters of the Gulf, as well as analyzing for the oil. They've also analyzed for the components of the dispersants, and thus far only one dispersant component, propylene glycol, was detected in a sample that was close to the wellhead. In addition, EPA is monitoring surface water samples for presence of dispersant components near the shoreline, and my colleague from EPA can discuss that. Finally, to ensure the safety of fishermen and consumers, NOAA prohibited commercial and recreational fishing in certain areas of the Gulf of Mexico because of the spill. Now that the wellhead is capped and new oil is no longer flowing into the Gulf, NOAA scientists are going back into the spill area and taking seafood samples to determine which areas are safe for fishing. An area is only reopened to fishing if visible oil is no longer present in the area, and only after the seafood passes rigorous sensory and chemical testing. To date, every seafood sample from reopened waters or outside of the closed area has passed sensory and chemical testing for contamination of oil and dispersant. No unsafe levels of contamination of the seafood have been found. NOAA has begun to reopen portions of the closed area, but only after being assured that the fish products within the closed area meet the Food and Drug Administration standards for public health and wholesomeness. To conclude, the attention at this point is focused on evaluating fisheries for reopening, shoreline cleanup, monitoring of subsurface oil both near shore and in deep water, and conducting natural resource damage assessment with our co-trustees. Thank you for allowing me to testify today, and I'm happy to answer any questions that you may have.
Thank you very much, Dr. LEHR. Our next witness is Mr. Donald KRAEMER. He is the Deputy Director of the Office of Food Safety at the U.S. Food and Drug Administration, where he is responsible for the administration of the FDA's seafood policy. He has been with the FDA since 1977. You may proceed, Mr. KRAEMER.
Good afternoon.
If you could, again, move that microphone in a little bit closer, please.
Good afternoon, Chairman Markey and members of the subcommittee. I am Donald KRAEMER, Acting Deputy Director of the Center for Food Safety and Applied Nutrition at the U.S. Food and Drug Administration. With me is Dr. Vicki Seifert-Margolis, Senior Advisor to the Chief Scientist at FDA's Office of the Commissioner.
Could you move that microphone in a little bit closer? A little bit closer, please. Just a little bit further closer? Good. Thank you.
We appreciate the opportunity to discuss FDA's role in ensuring the safety of seafood harvested from the Gulf of Mexico in the wake of the Deepwater Horizon oil spill. FDA is an active and integral part of the federal government's comprehensive, coordinated, multi-agency program to ensure that seafood from the Gulf of Mexico is free from contamination as a result of the oil spill. This program is important not only for consumers who need to know that food is safe, but also for the fisheries industry, which needs to be able to sell its product with confidence. FDA is working closely with the National Oceanic and Atmospheric Administration, the Environmental Protection Agency, other federal agencies, and state authorities in the Gulf region. I'd like to note the high level of cooperation that FDA has experienced among these agencies, both at the leadership level and among the technical and scientific staffs that carry out the research, testing, and analysis needed to fulfill our respective missions. The federal government is taking a multi-pronged approach to ensure that marketed seafood from the Gulf of Mexico is not contaminated as a result of the oil spill. These measures include the precautionary closure of fisheries, the surveillance and testing of seafood products, and a heightened emphasis on FDA's hazard analysis and critical control point, or HACCP, regulations. Beyond our ongoing work to ensure that currently marketed seafood is safe, FDA, in conjunction with NOAA and the Gulf states, has developed a strict protocol for reopening closed fisheries in a manner that will ensure the safety of seafood from these previously closed areas. We are also planning for additional research into potential hazards to the food supply presented by crude oil and dispersant chemicals. The primary preventive controls for protecting the public from potentially contaminated seafood is the closure of fishing areas that have been or are likely to be affected by the oil spill. Immediately after the oil spill, FDA worked with NOAA and the states to ensure that the appropriate closures were put in place. These closures are enforced by federal and state wildlife officials as well as the U.S. Coast Guard. The second element of our approach is a heightened emphasis on FDA's longstanding HACCP, H-A-C-C-P program for seafood, in which processors are obligated to identify hazards that are reasonably likely to occur and institute preventive controls to address them. The framework of our seafood HACCP program is proving its value in the context of this extraordinary public health challenge. Over the past several weeks, FDA has conducted more than 300 inspections of seafood processors in the Gulf region to verify that they are implementing controls to ensure that they receive fish harvested only from waters in which fishing is permitted. The third element is a verification that the other controls are working properly. This is the analysis of a variety of seafood samples that have been commercially harvested from Gulf waters. We are testing for polycyclic aromatic hydrocarbons, or PAH, the primary contaminants of concern in oil. FDA has so far tested for PAH in about 500 animals, comprising a variety of seafood, including shrimp, crab, and oysters, from open state waters. The results of all samples have shown PAH levels well below the levels of concern, usually by a factor of 100 to 1,000, essentially the same levels as were seen before the oil spill. With respect to the reopening of closed waters, FDA, NOAA, and EPA worked in close cooperation with agencies in the 5 Gulf states to establish a single, agreed-upon protocol for reopening to ensure the safety of seafood harvested from these waters. Under the protocol, waters impacted by oil will not reopen until 1. All oil from the spill is no longer present in quantities or forms that could contaminate seafood. 2, a scientifically valid sampling plan is agreed upon, and 3, all samples from the area successfully passed both sensory and chemical analysis to ensure that they contain no harmful oil residues. In our sensory analyses, expert examiners check the odor and appearance of raw seafood and the taste and odor of cooked seafood. Samples that pass sensory testing are sent for chemical analysis for oil, which allows scientists to conclusively determine whether PAH contaminants are present in the fish or shellfish tissue that could be consumed. To date, all samples have passed sensory testing for oil or dispersants, and the results of all chemical analyses have shown PAH levels to be well below the levels of concern, again, by a factor of 100 to 1,000. To date, Alabama, Louisiana, Florida, and Mississippi have reopened some portions of their coastal waters to recreational and commercial fishing, with concurrence from FDA that the criteria under the joint reopening protocol have been met. Additionally, reopenings are likely in the coming weeks. Finally, with respect to the impact of dispersants used in the Gulf on seafood safety, the current science indicates a low risk that these dispersants will bioconcentrate in seafood, and they are therefore unlikely to present a food safety concern. Further, NOAA and EPA data confirm that dispersants are not present at detectable levels in the overwhelming number of samples taken, water samples taken. However, out of an abundance of caution, and in order to gather additional information, NOAA and FDA are conducting additional studies to reaffirm that dispersants do not accumulate in tissues of fish and shellfish. FDA will continue to study the long-term impacts of chemical dispersants on seafood safety, and we will take any new relevant information into account and adjust our protocols accordingly. I see that I've exceeded my time, so I'll forego my concluding comments.
You may continue, sir.
Thank you. Then to conclude, Mr. Chairman, the safety of consumers is FDA's highest priority, and the responsibility we take very seriously. In close coordination with federal and state agencies, we have been proactive in monitoring this disaster, planning for its impacts, and mobilizing our personnel and facilities to take the steps needed to ensure a safe food supply. The protocols and approaches we have implemented are protecting American consumers while minimizing the negative impact on Gulf seafood processors. Thank you for the opportunity to discuss these important issues, and I look forward to answering your questions. Thank you.
Thank you, Mr. Kramer, very much. Our next witness is Dr. Paul ANASTAS. Dr. ANASTAS is the Assistant Administrator for EPA's Office of Research and Development and the EPA Science Advisor. He has conducted groundbreaking research on the design, manufacture, and use of environmentally friendly chemicals. We welcome you, Doctor. Whenever you feel comfortable, please begin. If you could turn on your microphone and move it in a little bit closer.
Thank you, Chairman Markey. I appreciate the opportunity here to testify on the important issue of dispersants and their use in the BP Deepwater Horizon crisis. We have now passed day 120 of the BP oil spill tragedy, a tragedy that resulted in loss of life, livelihoods, and put the Gulf Coast ecosystem in peril. We are relieved that the well is currently sealed and that dispersant use has been reduced to zero. We hope and expect that this will continue to be the case. As the President has said, this tragedy does not end with the sealing of the well. The President and EPA are committed to the long-term recovery and the restoration of the Gulf Coast, one of our most precious ecosystems. In addition to its other responsibilities with oil spill response, EPA continues to rigorously monitor the air, water, and sediments for the presence of dispersants and crude oil components that could have an impact on health or the environment. These data are posted on EPA's website and are publicly available. EPA has a role in the use of dispersants, which are chemicals that are applied to the oil to break it down into small particles. The dispersed oil mixes with the water column and is diluted and degraded by bacteria and other microscopic bacteria. Specifically, EPA is responsible for managing the product schedule of dispersants available in the oil spill response. The decision to use dispersants as part of a larger oil spill response is not one that EPA took lightly. When considering dispersant use, we are faced with environmental trade-offs. The potential long-term effects on aquatic life are still largely unknown. And BP has used over 1.8 million gallons of dispersant at a volume never before used in the United States. But because of our aggressive and constant monitoring, what we do know right now is this. Our monitoring data overwhelmingly confirm modeling results that dispersants are not present at levels of detection for our method. For the rare anomaly, we investigate to either confirm or disprove the validity of a detection. To put this in context, of the more than 2,000 NOAA-generated samples and the nearly 1,000 EPA-generated samples, there have been only 2 detections above the method detection limit. These were immediately investigated, and our monitoring continues. Our monitoring results also show that oxygen in the water is not being depleted to dangerous levels. Now, given the unprecedented nature of the spill, the EPA directed BP to identify less toxic alternative dispersants. When the company failed to provide this information, EPA decided to conduct this testing independently in a rigorous, peer-reviewed manner. Specifically, EPA conducted a Q-toxicity test to determine lethal concentrations of 8 available dispersants. First, we tested each of the 8 dispersants alone. Then we tested the Louisiana sweet crude oil alone. And finally, we tested mixtures of the oil with each of these 8 dispersants. These standard tests screen species called mysid shrimp and silverside fish to determine the relative hazard of each of the dispersants. These 2 species are widely considered to be representative of those found in the Gulf and were tested during a juvenile life stage when organisms are most sensitive to pollutant stress. The tests were conducted over a range of concentrations, including those much greater than what aquatic life is generally expected to encounter in the Gulf. EPA's testing delivered 3 important results. 1, All of the 8 dispersants, when tested alone, can be categorized as slightly toxic to practically non-toxic. 2, the oil alone was generally moderately toxic. 3, mixtures of oil in each of the 8 dispersants were no more toxic than the oil alone in these tests. All of these results indicate that the 8 dispersants tested possess roughly the similar acute toxicities. While these data are important, I want to emphasize that continued monitoring is absolutely necessary. EPA has directed BP to monitor for indicators of environmental stress, like decreased oxygen levels and increased toxicity to small organisms called rotifers. To date, we have not seen dissolved oxygen levels approach levels of concern to aquatic life. We have also seen no excessive mortality in rotifers. While more work needs to be done, we see that the dispersants have worked to help keep oil off of our precious shorelines and away from sensitive coastal ecosystems. The crisis has made it evident that additional research is needed. Congress has recently appropriated EPA $2 million to begin a long-term study on the impacts of dispersants. These funds will support research on the short and long-term environmental and human health impacts associated with the oil spill and dispersant use. We will also further our research efforts to include innovative approaches to spill remediation and to address the mechanisms of environmental fate, transport, and effects of the dispersants. EPA will continue to take science-based approaches to dispersant use. We will continue monitoring, identifying, and responding to public health and environmental concerns. In coordination with our federal, state, and local partners, EPA is committed to protecting Gulf Coast communities from the adverse environmental effects of the Deepwater Horizon oil spill. In conclusion, we will persist in asking the hard questions until we more fully understand the long-term effects of the BP oil spill and conduct the investigations required to enable the Gulf's long-term recovery. EPA is fully committed to working with the people of the Gulf, our federal partners, the scientific community, and NGOs toward the recovery of the Gulf of Mexico and the restoration of its precious ecosystem. At this time, I welcome any questions.
Thank you, Dr. ANASTAS, very much. The chair will now recognize himself for a period of asking questions. Dr. LEHR, intended or not, I think the reaction to the oil budget report that was released last week is one of relief. People want to believe that everything is okay. And I think this report and the way it is being discussed is giving many people a false sense of confidence regarding the state of the Gulf. Overconfidence breeds complacency, and complacency is what got us into this situation in the first place. Dr. LEHR, how much oil was actually discharged into the Gulf? Can you turn on your microphone, please?
Sorry. The best estimates of the combined efforts of the FRTG plus the Department of Energy National Laboratories, the best estimate to date would be 4.1 million barrels plus or minus 10%.
So it would be 4.1 million barrels discharged.
They were actually discharged into the environment. There was 800,000 barrels that was released from the wellhead, but was captured directly and pumped up above.
So is the 8 million that the 800,000 included in the oil budget baseline?
The oil budget baseline follows closely the form that is established by the Incident Command System Situation Unit for preparing categories of where to record the oil. And for the purpose of the response, that would be the standard procedure. So we follow the standard procedure, and yes, that is included in that budget for response.
But that oil went directly into ships on the surface and never was in the water at all. Is that correct?
That's correct.
The 800,000 barrels? So there were 4.1 million barrels that were actually discharged into the water.
That's correct.
Now, out of the 4.1 million barrels discharged, how many barrels are still in the Gulf or on its shores in some form?
Probably about 3/4 would still be, roughly, I would say, if we to go through the calculations that we have, the only oil that you would say that's actually removed from the environment would be that 800,000 plus the amount that was burned. The stuff that evaporated into the atmosphere is still in the environment. The stuff that's dissolved into the water column, the amount that dispersed, amount that was on the sheen on the surface or in small tar balls. So in that case, I would say most of that is still in the environment. It's not available for response, which was the purpose of the oil budget numbers. You cannot do any recovery operation on oil that's evaporated or is dissolved into the water column.
So even according to the calculations of the oil budget, that is the report that was released last week, between 60 and 90% of the discharged oil, that is the oil that actually went into the ocean, remains in the Gulf of Mexico, and that would be between 2.45 and 3.675 million barrels. Is that accurate?
I'd have to do the calculations here on my head, but when you were including your numbers there, I mean, the oil that evaporated, which was a substantial amount, whether it's still in the Gulf of Mexico, I don't, you'd have to look at which way, how it was transported by the wind. So I think you would want to stick with just the amount that would be in the water column or on the shoreline, and that would be the amount that we estimated as being naturally dispersed or chemically dispersed, and the amounts that are on the shoreline. Now, some of that's been recovered on the shoreline as well, and the amount that's been dispersed is biodegrading. We still are working to determine the rate. So the numbers that we put in the budget calculator for response purposes, to answer the questions about what's the fate of it in the long term, that's a different question. That's for the damage assessment.
So, Dr. LEHR, I'm interested in understanding how BP has performed in terms of removing spilled oil from the Gulf before it hits land. What percentage of the oil that was spilled into the Gulf was actually removed from the ocean? I'm talking about burning and skimming and actually removing the oil from the ecosystem.
Where we are.
That is, of
Yeah.
the four.
Now, of course, you want to.
Let me state it. Sure. Of the 4.1 million barrels of oil that actually went into the ocean, what percent was removed by BP?
I'd have to redo these calculations since we were based on the 4.9 million as opposed to. Are you talking about the
actually the only issue I think that the American people are concerned about is the 4.1 million barrels that actually went into the ocean. So it's important for us to discuss that issue and separate it from the oil that just went directly into the ships and never was in the ocean at all, because that's where the concern is, and people should have a very good understanding of what percentage of that oil has been removed thus far. So do you have a number or
well, you'd have to take the ratio of 4.9 divided by 4.1 and then multiply that by these fractions that we have down here for.
So if you could use your own chart, Dr. LEHR,
right,
and break that down in a way that could help us to understand of the 4.1 million barrels,
so
how much BP did.
Mm-hmm. So if you take the 5% that was burned and multiply that by the ratio of 4.9 to 4.1, and I must admit in the era of pocket calculators, I can't do that math in my head. and then if you take the amount that was skimmed, 3%, multiply that by 4.9, by 4.1.
Now, are you using 4.9 or 4.1 as you're doing this?
No, you asked me to use it with the new ratio.
Okay, 4.1.
Then I have to multiply those numbers by that ratio. I could get a calculator here and see what that ratio is.
Do you have assistants here with you? Has anyone accompanied you here this morning, Dr. LEHR? Could one of your assistants do that?
I mean, I've got a calculator here. So I need to multiply by 1.2 times each of those percentages. So, so roughly, the burned would then roughly be 6%, and the skimmed would be, this is their Georgia numbers. The skim would be 4%, roughly.
So between the skimming and the burning, 10% of the 4.1 million barrels would have been removed from the ocean, leaving 90% unaccounted for.
Well, there would also be whatever was recovered on the shoreline, which we didn't.
No, that's what I'm saying. So let's, in the arithmetic we're doing right now. So that's so the skimming, the burning is 6%, the skimming is 4%.
Right.
So let us continue then with the arithmetic. What else?
Okay, so then you had whatever was captured in the residual, and we have not quantified that quantity and how much of that as they do the beach recovery and so on. So I can't give you the numbers on that. We were, again, looking at it for response purposes.
So, again, let's recapitulate here for a second. 6% was burned, 4% skimmed, and an unknown amount was collected on the beaches. Is that correct?
Right.
And can you tell us the reason that has not been calculated yet?
It was mixed in with, you don't pick up just oil on the beaches, you pick up oil and debris, and that's a question of trying to separate that out. It's not a simple process.
Has there been even a range that has been put together in terms of some estimate of how much oil that might represent?
There may have been. I'm not aware of it. I could get back to you and get that answer to you.
Okay, well, in the wake of the Exxon Valdez spill in 1989, both the Government Accountability Office and the Office of Technology Assessment published reports looking at the capacity to recover oil after a major spill. They found that given technologies available at that time, we could really only recover 10 to 15% of the spilled oil. So it seems to me that BP's oil recovery effort comes in on the low effort of what was achievable 21 years ago. You seem to have come in at the number of approximately 10% plus whatever was on the beaches, but still within that range of 10 to 15% that was determined to be recoverable after the Exxon Valdez spill. Would you agree with that?
Yeah, I mean, in terms of the actual, the oil on those categories. Now, there was, of course, in this case, the unusual event of a large amount of natural dispersion and the addition of large amounts of, a record amount of, as far as I'm aware, of chemical dispersants, and that's considered a type of response. So one would have to say, how do you weigh that?
I understand, but I'm just talking
about. In terms of the standard mechanical and burn operations, beach recovery, I would say, yeah, this was about average for what we'd seen from major.
I'm just trying, if I could, Doctor, I'm just trying to divide the question so that the public can understand what it is that we're talking about. So in terms of just recoverable oil, it's somewhere in the range of 10%.
Yeah.
And in my mind, that is not a passing grade. only 10% of the 4.1 million barrels actually having been recovered. I think we all saw this coming, and with all of BP's talk about using golf balls and nylons and hair to clean up the spilled oil, I think it's important that even using a 21-year-old grading system, that BP has done a very poor job in cleaning up the Gulf. So, Dr. Laird, throughout the entire BP saga, I have pushed for BP and the Unified Command to make this process as transparent as possible. The way I see it, the more people we have independently analyzing and verifying the data and information associated with the spill, the better and more informed our response decisions will be. With regard to the oil budget, is this something NOAA does as part of the operational response to a major oil spill?
The oil budget is a traditional part of a response. As I mentioned before, it's there's a special form that's filled out as part of the situation unit in the incident command system. The standard procedures for that use, amongst other things, a model that was developed by NOAA, but also they use some other techniques such as observers estimating the size of the spill. In the case of this spill, because it was so large, because it went on for so long, and in particular because it was occurring at a mile underneath the water's surface, it was necessary to develop the special tool, which is what we did with the budget calculator. Now, I've noticed in the press that this is called the NOAA budget calculator. I'd like to receive credit for that, but one thing in science that you have to do is to recognize the contributions of others. And so this really was a joint effort of both government agencies and the outside experts in the field to develop this tool.
So, Doctor, is there an established methodology for making the oil budget calculations?
There is a standard form that you would calculate to divide the budget into, but in terms, there is a normal procedures that we had to modify because of the circumstances for the spill.
In the case of the Deepwater Horizon spill, how long has NOAA been calculating an oil budget to guide the response efforts from the Unified Command?
In terms of the incident command, we started working early in, I think I believe in either June, starting to work on the development of the tool, and we're providing guidance for sometime in July for the incident command.
So has NOAA been using the established methodology for calculating an oil budget in this case?
I'm going to have to ask for clarification. What do you mean by it? We did use the standard procedures for estimating oil for each of the techniques based on methods that have been used in the past, but were modified. Let me give you an example. In calculating dispersion, natural dispersion, this is based on looking at something called the energy dissipation rate that's due to breaking waves. Now, we, of course, obviously in the case here, where we had a plume that was subsurface, we didn't have breaking waves, but we did have an energy dissipation rate. And we had to then employ some of the experts that worked on the FRTG to help us to calculate that energy dissipation rate so we could get a new estimate for natural dispersion. In the case of the evaporation, we know we have some standard models for estimating the evaporation of Louisiana sweet crude. It's in our oil library database, but that's for spills that happen at the surface. And the spills that are coming from a mile deep, there's some dissolution that occurs before it gets to the surface. Many of the same molecules that would evaporate on the surface become dissolved in the water, so we had to modify that to handle those cases. So it was the standard procedures, and to the extent that we had to modify them for the specific instances that happened in this spill.
You have to be careful. Look at that again. Can I ask, has NOAA made available the background data and formulas that were used to reach conclusions on what happened to the spilled oil?
In terms of the one component, in terms of the flow rate, the NIC will be has reports that have been released on that. In terms of the oil budget calculator, which is what I assume that you're referring to, this was an oil spill emergency, not an oil spill experiment. When we put together the team, our priority was to get an answer as quickly as possible to the incident command. Now the technical documentation is being written and will be peer reviewed. It will be long, it will be boring, it will be filled with graphs and charts and all the references and the passive voices that are typical of such reports. And I assure you it will bore everybody except for those handful of us who actually like to do oil spill science. But for those, I've noticed that some of our academic friends have asked us for this. I would, for the younger friends, I would suggest that patience in this case is a virtue. In an emergency, you first get the answer. You do not tell Admiral Allen that he's got to wait 3 months while your report goes through peer review, but that will come. We welcome people's comments on it. I would encourage the new people who are coming into the field from from non-traditional areas of this to stay interested in it. We'd like to welcome the new blood, but you're going to have to wait a little bit for that report to get out.
Well, I appreciate the desire to complete a full peer review, Doctor, but you've already issued 4 pages of findings and a 10-page supplement that explains some of the calculations in greater detail. If much of this oil budget is standard procedure for NOAA in response to an oil spill, why can't that information be made available sooner, especially given the historic issues that many independent scientists have voiced regarding the conclusions of this report?
Well, I would say this. I would prefer, and I think as all the scientists would prefer, that because the emergency is, the questions now are on a different time frame when we move from the response to the damage assessment, that it is better to take the time to do it right. Now, yes, some of the methods are standard, but some of them had to be modified, as I mentioned in my testimony, in terms of the evaporation calculations and the natural dispersion. We're doing a thorough literature survey because, again, we are understanding that this report is going to be looked at not only by oil spill scientists who've been doing this for 20 years, in many cases are contributing to the report, but by other scientists who are coming to this with this is their first major spill event. So we want to provide a complete document here that will answer all their questions. And I think
let me ask this. Will NOAA agree to make available to the public the citations of the scientific literature, formulas, or actual algorithms that would allow independent scientists to evaluate the report's findings?
Of course.
Will you release that now?
It's still being compiled.
You've already released a report last week. Could you give us, for the public consumption, the citations of the scientific literature, formulas, or actual algorithms that you used in creating your oil budget?
All that, first of all, and again, I'll come back to this is not it is not a NOAA product. This is a product of a joint effort. And
what we're trying to do, Doctor, is to get at the methodology so that we understand what was used in order to produce your initial oil budget. You're saying that it has to be reviewed for some time in order to determine whether or not you got it right. And so in order, I think, to ensure that we have this done in a time frame that provides the information to the residents of the Gulf of Mexico, that you release these algorithms, you release the scientific literature that you relied upon, so that there can be independent eyes, independent judgments that are also allowed in real time to be able to make judgments as to whether or not the formula which was used was the correct one to be used, given the consequences to the public if that formula was not constructed accurately. Will you, in other words, would you support making that information available to the public? Speaking for NOAA.
Well, for NOAA, and I would assume that all the experts that contributed will also be releasing this information. That's what the purpose of the report is. Representative Markey, what we're doing in this case, is going through the standard procedure, which is done for a scientific report. We get the experts; they all contribute to the report. We send it back to them for them to look at, to make sure that we've got their comments and their opinions and their assessments correct. And then we send it out, as you say, to independent scientists. That's what a peer review is. We send it out to people, and we'll welcome recommendations for peer
But
review
when will that
well.
happen, Doctor?
What's that?
What is the time frame for that to happen?
Well, it's been delayed by a week because I'm having to come here, but we're hoping to get it out within 2 months.
2 months, yes. That's not timely enough, Doctor. That's the problem. That's what we're trying to get at right here. We're trying to telescope the time frame that it will take in order to get that information into the hands of independent scientists. So you don't want to make all of the data and models available, but you've given us conclusions that result from these models of the data. You then say you don't want to make the models and data available to outside scientists because you are still having everything peer-reviewed post-release of your budget report. That is, to me, unacceptable. We need to have that information. The report that you released last week received international attention. There are many people who are making decisions based upon that report. So it is important right now, Dr. LEHR, for that information then to be made public, so that not only is it being peer-reviewed in the regular process, but because of the real-life consequences for the lives of the people in the Gulf of Mexico and outside of the Gulf of Mexico, because of the toxic nature of the material in the Gulf, that information be made public. There is too long of a gap that is going to elapse under the process that you have adopted. The real issue here is that the public has a right to know right now what is going on in the Gulf of Mexico. And your report should be analyzed by others right now so that we're sure we got it right. Because if your numbers are wrong, 2 months from now could be too late in terms of the remedial recommendations which are made to the public, to the fishing industry, to the consuming public in terms of the consequences for their families. So I ask again for you to release that information, that data. The flow rate team estimated that 4.9 million barrels of oil flowed from the Deepwater Horizon well. The uncertainty of this estimate is plus or minus 10%, as you said. Does NOAA have certainty with regard to the figures for the estimates of what happened to all 4.9 million barrels? what is the best and worst case estimate for the residual oil that remains in the Gulf?
We have, we do, as part of the calculator, do have the estimates of uncertainty for each of the various processes. So, for example, in terms of the burn, there are some ASTM standards for the burn rate that were applied to this spill. It gives us a high degree of confidence, and we have very low uncertainty for the estimates for that. For evaporation and dissolution, again, we have taken samples and matched them up with models from both NOAA, from the Environment Canada, and from a large research organization in the European Union, and those results match closely, so we have a fairly confident on those values. Now, when we get into the dispersed oil, the uncertainty becomes becomes larger, particularly for the use of the chemical dispersant subsurface, which is a new experience to us. And we were very conservative there, but we have a large error bound. Now, we've employed the expertise of the National Institute of Standards and Technology, who has brought in some very excellent statisticians to calculate the net uncertainties on it. That's given in those extra pages that I believe that you were given there. But that will also be in the final report. And Representative Markey, I will commit today to do whatever I can to speed up the report. I appreciate the concern on it. I hope that you and the public and the other academics appreciate that because of the importance, because of the points that you just stressed, we want to make sure that it's done right. And that's why I'm making sure that we brought in the experts and we're having a peer review.
Here's the thing, Doctor. You shouldn't have released it until you knew it was right, because so much is going to depend upon that release. And if you are not confident that it is right, then it should not have been released, okay, because it basically sent a signal with regard to how much of the problem remains. And that is really something that is obviously of great concern to people who live in the Gulf. They don't want to be forgotten. They don't want this to be downplayed or lowballed, which is in some quarters what has happened since that report was released. So I think it's important, since it has been released, to be examined right now so that we can be sure that those numbers were accurate, and independent scientists can quickly look at the formulas and corroborate or question. But it should not be something that's done in a boring academic setting over a prolonged period of time. It is something that has to be done in a dynamic setting in real time because of the resources that may need to be dedicated to this problem to ensure that it is remediated in a shorter period of time than otherwise if your estimates are inaccurate. So that's critical. And from a political perspective, the longer the time that elapses is the lower the political pressure and the public attention will be there to ensure that the resources are brought to the problem. And so we have to make sure that we do this in a timely fashion so that, unlike the Exxon Valdez spill, we actually do something in real time so that everything that can be learned about it is learned about it. And you agree, Doctor, that this is at least, that is the amount of oil which is still in the Gulf of Mexico and unaccounted for is at least 5 times the size of the Exxon Valdez spill. You do agree with that?
Oh, I agree that this is, and I also would note that that NOAA is taking a lead role in monitoring the oil that's out there. We'll continue to do that. I don't think the report, and it should not be interpreted as saying that somehow this spill is over with.
No, it's not that it's over with, but there was an optimistic spin in some quarters that that was placed upon that report, and since that is happening in real time, then the independent evaluation of that report must happen in real time, because if it's wrong, then many opportunities for a calibrated response to to the defects in the report will have been lost. And so that's why it's important for you to surrender this information now to independent scientists. So according to NOAA's oil budget, 408,792 barrels of oil were chemically dispersed out of a total of 4.1 million barrels, approximately 9% of the total oil in the Gulf of Mexico. This means that 43,900 barrels of dispersant were needed to get rid of 408,792 barrels of oil. This means that 1 barrel of dispersant dispersed just over 9 barrels of oil. Yet, according to your budget documentation, a dispersant to oil ratio of 1 to 20 is considered successful. Dr. LEHR, it seems to me that the ratio used in this disaster of 1 to 9 would not be successful by NOAA's own definition. Would you agree with that?
What we did for, and this was an area that we had the hardest time, excuse me, calculating, was the effectiveness of the chemical dispersant. The dispersant that was applied subsurface were what we would call ideal conditions. We made sure, that the oil was the dispersant was being injected into the oil, so it was making direct contact. It was a very turbulent flow regime there. So this would be the ideal conditions for dispersant operations. We asked the people who make a living applying dispersants what they thought would be the effectiveness, and they had numbers as high as 30 or 40 to 1 ratio. We looked at the literature, and the oil industry literature suggested that a successful operation was 20 to 1. So we decided to be conservative and say we'll go with the 20 to 1. We may very well have underestimated the effectiveness of that subsurface dispersant. Now, at the surface, where a lot of the oil, all of the dispersant was applied, they were applying on oil which had partially weathered and had partially emulsified. The viscosity was high, and according to past spills, dispersants would have been not as effective. But there was a study that was done by Sintef in a research group out of Norway with this emulsified oil using these dispersants that said that it was showing some effectiveness. Plus, there were some observations on scene by NOAA personnel and Coast Guard personnel that suggested that the surface operations were being at least partially effective. So what we did was to scale down what we would estimate would be the effectiveness of the surface operation by, I believe we estimated it would be like 4 or 5 barrels per amount of dispersant sprayed, and that would take into account that some of the dispersant did not interact with the oil. You're spraying from the air, you don't always hit the oil. And secondly, that the fact that the oil had emulsified to such an extent that it was more difficult to disperse and form the small droplets that are necessary for the oil to disperse in the water column.
So, Dr. ANASTAS, according to the budget documentation of dispersant to oil ratio, 1 to 20 is considered successful, but this was a ratio which was 1 to 9. Do you believe that that constitutes a successful application of dispersant?
I think my colleague, Dr. LEHR, noted the significant uncertainty in the estimates of dispersion. All of the evidence, all of the monitoring that was conducted in an ongoing way that was required by EPA during the application, especially of the subsurface application of the dispersant, showed effectiveness. We ensured that through fluorescent spectrophotometry that particles were being formed. This was a high-energy system. We have reason to believe, and evidence shows, that it was an effective and relatively efficient.
So given your own numbers and your own analysis, how successful would you say that it was?
Well, I don't think that there's a way to measure the ratio between chemically dispersed and biologically dispersed oil. So I don't think we can have precise numbers. I do think that the estimates, as Dr. LEHR noted, of whether it's 20, 30, or 40 to 1 in terms of a ratio, would be more in the potentially in the ballpark.
Okay, well, dispersed doesn't mean exactly the same thing as gone, does it?
No, it does not.
For example, if I put a spoonful of sugar in my iced tea and stir it, the sugar is dispersed. You can't see it. But if I then drink the iced tea, it still tastes sweet because the sugar is still there. The sugar is dispersed, but it is present. Isn't that somewhat analogous to the situation we face in the Gulf with this dispersed oil as well?
Not exactly. The sugar dissolves in solution. Dispersant means that it's being broken up into small particles that the whole purpose of which is to make them more ingestible and digestible by the microbes, because the only time that oil actually goes away is when it's degraded. Now, that degradation can happen through biological processes. It can happen through physical processes. Physical processes, when it's broken down by the water itself, is called hydrolysis. When it's broken down by temperature, it's called thermolysis. When it's broken down by light, it's called photolysis. These degradation processes all combine, and the whole purpose of the dispersants is to make it more accessible to these degradation processes.
What is the time frame for that process to take place? How do you measure that in terms of the actual amount of oil that is, as a result, more subject to being consumed because the dispersant has been released? How can you measure that over such a vast area?
There have been studies done even by the EPA and its partners, and part of the rationale for applying dispersants is because we have seen rates of degradation increase by as much as 50% with the use of dispersants.
Did you say 15 or 50?
50%. 50% over those untreated.
Okay, thank you. Dr. LEHR, government scientists have now estimated that 4.9 million barrels of oil escaped from the BP Macondo well, but that number does not include the methane that also came out of the well, much of which entered the Gulf of Mexico. Although the impacts of methane are not well understood as that of oil is understood, we know that it has the potential to cause harm when released at such significant levels above the natural seepage of methane in the Gulf. As a part of the Natural Resources Damage Assessment and Associated Restoration Plan, will NOAA be looking at the impact of the release of methane from the BP well?
In terms of the effect, I would believe that the NERDA folks would take that into consideration for sure. Yeah. Now, I'm not part of the damage assessment team. We have a different group that does that, and the budget calculator did not take into account because it was a oil budget calculator. There is no response to dissolved gases that you can't put skimmers out and so on. So that's why it wasn't in the report that you saw. But in terms of the damage assessment, certainly you would take into account all the hydrocarbons that were released and what the effects they would have on the environment.
Okay. Just a few weeks ago, in response to a letter I wrote, FDA explained that while it does not presently monitor for dispersant chemicals in the tissue of seafood, the agency is working closely with NOAA to conduct further studies to determine if dispersant chemicals or their metabolites can bioconcentrate in the flesh of seafood species. Mr. KRAEMER, what is the status of these studies?
Mr. Chairman, I'd like to refer this question to Dr. Margolis.
Okay, could you identify yourself for the record, Doctor?
Dr. Vicky Seifert-Margolis. The status,
And what is your title, please?
I am the Senior Advisor for Science, Innovation, and Policy in the Office of the Commissioner of the Food and Drug Administration.
Okay, fine.
We have been working with NOAA on developing chemical methodologies for the detection of one of the major components of dispersant, which is dioctyl sulfosuccinate sodium salt, or DOS. This component is about 20% of the total Corexit dispersant which was applied in the Gulf. Essentially what we've done is two series of studies where we're exposing crabs and fish in tanks in controlled settings to DOS at 100 parts per million, which is an effective concentration of 20 parts per million of the DOS. We then do exposure times of 24 hours with subsequent washouts in clean salt water for 24, 48, and 72 hours, and then assess the concentration of DOS in the hepatopancreas or liver, as well as the muscle tissue. We have preliminary data to date suggesting that there is not any bioconcentration of DOS in the hepatopancreas or in the muscle
Could you
tissue
explain
of
what
crabs.
DOS is so that the public who is watching can understand what that is?
Sure. DOS is a detergent, essentially a detergent-like compound that's actually found in a variety of products, including a number of over-the-counter medical products. It is used to help disperse the oil, but it is generally an inert, non-toxic substance. And there have been significant studies on toxicity of DOS demonstrating a lack of toxicity of this particular component of the Corexit.
All right, please continue.
So essentially, we conducted these tank studies, and we found no evidence to date of concentration of DOS in the crabs and some shrimp that have been tested so far. We are still actively assessing these samples in the controlled setting, and additionally, we are able to go back to all of the retrospective samples which were collected because this particular component is present in the fraction or extract that we made for monitoring PAH for the reopenings.
What about the other components of Corexit in addition to DOS? Have you done the analysis of the other components of Corexit, this chemical that was shot into the ocean, in order to determine the toxicity of those components?
We have not. We have started with this as a marker for DOS because it is one of the principal components of the Corexit and therefore will be very readily detectable. So it essentially serves as a marker for the dispersant.
What is the time frame that you are going to use in order to do an analysis of the other components in Corexit to determine whether or not there is a toxicity, there is a danger that could attach to it if human beings consume that chemical?
Some of the other components that are present in Corexit, such as the petroleum distillates, would be found in our PAH analysis as well. So it would be difficult to distinguish those from petroleum distillates in the oil itself. We are not currently looking at any of the other components of Corexit.
You are present. Could you repeat that finally?
We're not currently doing tests on the other components of Corexit right now because we wanted to establish the methodologies using the principal, one of the principal components, which we felt we could detect readily as a first step.
How long will it take you before you actually conduct experiments on the other components?
I can't speak to that because it's not clear whether or not we have the methodologies in hand to detect all those at the present time.
So if you find DOS in your seafood samples, then what?
Then we would consider that as something that we would need to go back and reevaluate the samples. for a possible presence of dispersant.
Are there potentially other components in Corexit that are known to be toxic?
There are a number of components of Corexit. I think the EPA could probably speak better to toxicity studies that have been done on the various components of Corexit.
Okay, Dr. ANASTAS, are there other components in Corexit that have been known to be very toxic?
I guess I'd first start off by saying that the testing that we conducted, that the administrator ordered conducted was on Corexit itself. So, of course, when you're looking at the entire formulation, all of the components and their contributions to toxicity would be considered. And it is important to look at the formulation as a whole. So the toxicity results that I reported in my opening statement.
So are you saying that as a result that there's no point in even bothering to examine the other components in Corexit because you've already studied Corexit?
No, I'm saying that when you do toxicity studies on the Corexit as a whole, you are, in essence, doing toxicity studies on the components.
And what I'm asking as a result, if I can go back to the FDA, does that mean that there's no reason to do any further study of these materials, even though some of them are known to be toxic?
Yeah, Mr. Chairman, FDA, first of all, is fully aware of what are the components of Corexit. And we've looked at each one of these for toxicity, and I think we've, as you are aware in our response to your letter to the agency, each of these components are low toxicity to humans. I think we have to separate here the distinction between toxicity to marine animals, as I think was the concern that EPA was suggesting, from toxicity to humans if it's present in the flesh of the fish. So of course FDA's concern is the latter, toxicity to humans if it's in the flesh of the fish. We have looked at each of these components of Corexit, and they are all very common household constituents. So they're in things such as lip gloss and toothpaste and a variety of over-the-counter drugs. So they have been approved for use for consumption by people. These are components that FDA reviews for food additive purposes, also reviews.
So let me ask, you have yet to put in place, though, a test in order to determine whether or not any of these chemicals are in, any of these components are in the fish. Is that correct? You've only done a study so far on the DOS, but not on, as a marker, but not on these other chemicals. So as you're sitting here as the FDA and representing the public's interest in determining whether or not these fish are safe to eat, it is without having completed the study in terms of these actual component chemicals inside of the fish. Is that correct?
Yeah, I'd like to, if you don't mind, put that question in the context of what we have done, and I do intend to answer your question specifically. But the first question that FDA wanted to ask or answer with respect to dispersants is whether the constituents of or the components of the Corexit, what do we know about those, and what do we know about whether, one, they can get into the flesh of the fish, and two, if they were in there, what would be the risk to humans? The answer to all of these is that they have a very low potential to get into the flesh of fish. That doesn't mean they won't get in at any level. It means that they have a low likelihood of getting into the fish and are highly unlikely to accumulate at levels above what is in the environment, which is, we believe, is comforting. The second is, the question, as I mentioned, is do the components are they toxic in and of themselves? And as I said, we are aware of all of these components, and they have common uses in products that are either intentionally consumed or, as in the case of lip gloss, do get consumed as a matter of course because of the way they're used. And these components have approval levels in each of those uses. So, and those levels are much higher than the levels that, under any circumstance, you could imagine would end up in the flesh of the fish. So it is true that we've decided that in the case of DOS, in particular, at least as a starting place, we are looking to see whether we want to confirm in a definitive study what we already believe we know the answer to, and that is that it's unlikely to bioconcentrate. And as Dr. Margolis put forward a minute ago, the studies, although just underway at the current moment, but the preliminary information is very suggestive that they will not bioconcentrate. So again, confirming what we believed we already knew. It's a reasonable question to ask if we can look at the other components. I think that's something that we ought to do.
Just so I can understand, Doctor, so right now, in the parts of the Gulf that have been reopened for fishing, you have okayed the consumption of that food, those fish, even though you haven't completed testing on the component parts of Corexit. But with the belief that it does not accumulate in fish at a level that would pose a danger to the public as they consume that fish. Is that correct?
It is correct to an extent, but what I would like to clarify is that we are doing some analysis of the fish. This is through the sensory testing that I explained, or that I mentioned earlier. And to give you an understanding there, these are experts who are trained. I think there is a misunderstanding by many about the nature of this test. Quite frankly, these are folks who go through significant training. Not every one of them can get through that training and demonstrate the skill to be able to pick up different odors. But the panels that we have in place in the Gulf Coast now, these are both NOAA and FDA people working together, are truly expert, and they've been calibrated against the standard of seawater, oil, and dispersant that was collected at the well site, so they can detect that combined odor. They were also calibrated specifically against the odor of dispersant, which has a much milder odor but still detectable. And so all of the samples that we're using for reopening of waters have been run through this analysis. We recognize that there's more comfort in having a chemical test, and that's the reason that we've engaged with NOAA in the development of the chemical test for the DOS component. We believe it's highly unlikely that dispersant will be present by itself, but there's certainly the possibility that it could. So that's the purpose for that analysis, for the development of that test capability. But again, I don't want to suggest that we lightly came to the conclusion that the components of Corexit are unlikely to accumulate, and if they did, are non-toxic. There's an extensive body of science around all of these components, which FDA has looked into. So we are, as we have said and made in public statements, we are confident that that based on the current science, the likelihood for bioconcentration in fish is very low, and should it occur, the toxicity of those components would be very low. The studies that we're talking about are really there because of the unprecedented nature of this spill. We want to be able to assure the public that we have a test, but we don't believe there's any risk to the fish that's already or caused as a result of the fish that are already on the market.
In the same letter, FDA stated that it defers to EPA to determine if dispersant and oil residues can accumulate in aquatic plants and eggs. Dr. ANASTAS, can oil and dispersant bioconcentrate in fish eggs?
The properties of oil and the degree to which it dissolves in fat can allow oil to, in principle, enter into fat tissues and potentially enter those biological systems. All of the models that we've done on the dispersants would certainly suggest that we would not see the dispersants entering into and bioaccumulating and biomagnifying in the way that oil may.
Is it possible that a fish may be caught and test clean in the adult tissues but contain eggs that have high levels of these toxic chemicals?
I'm not aware of a mechanism by which that could occur.
You believe that it could occur?
No, I am not aware.
You're not aware
of a mechanism by which that could occur.
Do you believe that further testing on eggs meant for human consumption be performed to ensure that all fish products on the market are safe?
I'm sorry, if you could repeat that, please.
Should further testing on eggs meant for human consumption be performed to ensure that all fish products on the market are safe?
I would defer to my FDA colleagues on that. I would have to say that that the more data that we have, the more sampling we have to verify, this is always good. That we need to rely on the data, and the data needs to drive us.
Dr. LEHR, how do FDA and NOAA ensure that fish that were located in oiled waters and were contaminated with toxic chemicals from the oil are not then swimming to areas that have been cleared for fishing?
Well,
Can you turn on your microphone, please?
the presumption here is that when you take it, the fish is guilty until proven innocent, so to speak. So when they do their sampling, the fish has to, you don't assume that it's clear. You assume that it has to pass the tasting tests, and only then, if it passes those, does it then go to the laboratories of NOAA for the testing for the PAHs. So I would say that the case here that that we have that it would not necessarily, we would take that into account. However, to be on the safe side, there's a 5-mile buffer between the area of where the places would be open or have not been closed in the first place and where oil was appeared. So you have to be an athletic fish.
Are you right now engaging in intensive testing where the oil is still present in large quantities? Are you doing testing there?
The testing for the fish is being done in areas where the oil is no longer present on the surface.
Where the oil is?
It's in the areas where either oil was never
present.
Never present, or in areas where it hasn't been present for some time. Then they do the sampling, and then of course every sample has turned out to be negative. They've never detected any PAHs in the fish.
Okay, so, and I'm just going to use a hypothetical, and I don't know how accurate this is, but let's just use it as a hypothetical, that the bluefin tuna, which is ultimately caught up off of Georges Bank, off of New England, does spawn down in the Gulf of Mexico. Let us say, just for the sake of the discussion, and only for the sake of the discussion, that some of that spawning is going on right now inside of the much more oiled area of the Gulf. We know that those fish are ultimately going to migrate up off of the coast of New England. What is the testing for that fish or other fish that's going on inside of the oiled area that will ensure that it is safe when it finally reaches the part of the ocean where that fish or any fish is caught?
And I think I'm going to I'll defer that question to experts that can answer that better than I can right now.
Is there someone here who can do that for us?
We don't have a NIMS.
I'm sorry, can you move up to the microphone, please, and identify yourself?
Chairman Markey. Sorry. Chairman Markey, I'm John Gray. I'm the alleged affairs person. We don't have a person from the fishery service here. We had one witness, and it was going to be Mr. LEHR. So we can get those answers to you, but we don't have that person here for you.
I think that's an important
Yes.
issue to be resolved in people's minds, because it just seems, I think, to someone that thinks about stationary, territorial entities in many instances. We're seeing sharks all up and down the coastline of New England, and they don't seem to limit themselves just to a 5-mile radius right now. And just to say, don't worry about it a few miles further away, the sharks only stay within a 5-mile radius, doesn't seem as though that would be the kind of warning that the public would think was sufficient in order to guarantee the safety of their family. So I think this is important information for us to have, and the more that it can be put in very simple terms for the public, is I think the better it will be for the fishing industry and for the consuming public. Mr. KRAEMER, you're seeking recognition, Mr. KRAEMER.
Yeah, I would just like to respond a bit on that. I think there are several answers to that question, or several pieces of the answer to that question. The NOAA testing has included testing outside of the closed areas, and the purpose of that testing was to look for whether or not, first of all, to determine whether or not the closures were sufficiently protective. So this 5 nautical mile buffer zone that was put around it, we believe is sufficiently protective. The question, though, comes, was it sufficiently protective? So testing was performed outside the area in which the closures were. Beyond that, both NOAA and FDA have done market sampling. So this is fish that were commercially harvested, certainly in appropriately open waters, and then so samples were collected there, and we believe we would have picked up any indication that there were fish that had higher than expected levels. And then finally, especially true for finfish, they clear the PAHs very rapidly from their body, usually within a matter of days. So a scenario of a fish that's contaminated in a Gulf making it up to New England, I think, is highly improbable, and we don't believe that that would be something that consumers should be worried about.
Are you actually testing for that, though, given the unprecedented underwater experiment?
We are testing Gulf product that is product that's been commercially harvested in the Gulf, and that is currently being marketed. So we are testing that product, and again, it is not showing levels of PAHs above the background levels that were there before the spill occurred. So we believe that the fish coming out of the Gulf do not have levels that are of concern.
Mr. KRAEMER, is the FDA monitoring seafood recovered from the Gulf for the presence of heavy metals present in crude oil?
We are not, no, but there is a NOAA program, the Mussel Watch program, that it's a bit of a misnomer in the Gulf in that it's not mussels that are being tested, it's oysters. But these are what we would call a sentinel species, in that they are the species that is most likely to absorb contaminants, including heavy metals, the most likely to hang on to that within their flesh, and also the species most likely to bioconcentrate, that is, have it at levels above what would be in the environment. So this program has been in place for decades in the Gulf, so we have a very solid, well, in fact, nationwide, so we have a very solid background level. We know what the levels of these contaminants are. It includes any of the heavy metals, for example, that you would be concerned about
But
here.
are you monitoring for it right now?
And I would defer to NOAA to answer what has been done on this, but I wanted to mention that FDA is not, but the NOAA program, we believe, is a good sentinel program for
Let me go to NOAA then.
elevated levels.
It's because it's my understanding that compounds like mercury, arsenic, and other heavy metals that are present in crude oil have the ability to accumulate in the tissues of fish in levels that may cause harm, particularly to pregnant women and children. Has the FDA or NOAA here examined seafood for the presence of heavy metals? Dr. LEHR.
There is some monitoring for heavy metals that are being, as part of the Mussel Watch program in the area. Again, I'm going to defer to my colleagues at NIMS to answer that correctly, and we'll get back to you with an answer for that.
So, Mr. Kramer, back over here at FDA, you don't screen for heavy metals. You think that NOAA may, but
yes,
the witness today does not know the answer to that question.
I hate to speak for NOAA in this regard, but it is our understanding that NOAA has collected a sampling run, if you will, from one end of the Gulf to the other, where they would normally collect for the Mussel Watch, but that the results are not yet back. So we don't have analyses of them. We do not expect to see an increase based on this spill, but certainly those results will be confirmatory of that.
Well, Mr. Kramer, I wrote a letter to the FDA on this issue of heavy metals 6 weeks ago, and I have yet to receive an answer from the FDA. So,
and I apologize for that, Mr. Chairman. I would be happy to respond to those questions at this time. If
yeah,
like.
I would not have asked the question if I did not believe that it was important. I mean, heavy metals obviously have a danger that attaches to them, and to have this kind of regulatory black hole be created here today between the FDA and NOAA in terms of knowing what the response is to testing for heavy metals in these fish, which we know can accumulate in fish, is something that obviously should have been identified within the last 6 weeks since I wrote the letter. When can I expect that response from the FDA?
In a matter of days.
Thank you, Mr. Kramer, very much. Dr. LEHR, how does FDA and NOAA ensure that fish that were located in oiled waters and were contaminated with toxic chemicals from the oil are not then swimming to areas? I'm sorry, I've already
I think you asked that
question. Let me move on to the FDA and NOAA. You have agreed on a protocol to examine when closed federal harvest waters can be reopened. That protocol relies heavily on surveillance tests and sampling that generate data about the concentration of particular contaminants found in seafood. It is my understanding that there have been fishery reopenings in state waters within 3 miles of the coastline of Louisiana and Mississippi. Does NOAA and FDA have access to the data that is used to drive the reopening decisions in state waters within 3 miles of the coastline of Mississippi and Louisiana? Mr. Kramer.
Thank you, Mr. Chairman. The answer is yes. The protocol that was developed jointly by FDA, NOAA, and EPA, along with the 5 Gulf Coast states, calls for the states to provide that data to FDA and NOAA. I should say that for reopening purposes, the states are acting under their own authority, as I think you know.
What role does the FDA and NOAA have in the opening and closing of state waters?
When the state has made a decision that they would like to reopen a portion of their waters for a particular fishery, for example, for finfish or for shrimp, they develop a sampling protocol or plan, and that identifies how many of each of the species and where they're going to be located that they intend to collect. FDA and NOAA review that proposal and either concur with it or make recommendations for changes. And at that point, the state then goes out and collects those samples and submits them to the NOAA laboratory in Pascagoula, Mississippi, which is where the sensory testing that I described a minute ago is performed. If a sample passes the sensory testing, then it is submitted to a chemical laboratory, and this is where the samples split. If it's federal waters, which isn't the question you raised, the sample would go to a NOAA laboratory. If it's state waters, then the sample is handled by FDA or one of the state laboratories that we have under contract, and that's where we perform the analysis for PAH. The sensory analysis, as I mentioned, is for odors indicative of oil, as well as odors that are indicative of oil contamination. I'm sorry, of dispersant contamination.
Okay, so can the FDA and NOAA state unequivocally that fish caught in the state waters are safe to eat? Can you state that unequivocally?
FDA is and has expressed confidence in the fish that are commercially marketed from the Gulf Coast. As I said, I didn't mention that the sample results then come back to FDA and NOAA for review, and FDA then provides its concurrence to the state before the state reopens. So we are aware of the state of the oiling in that area, and we are aware of the levels of the results of the analytical tests before the water is reopened by the state. So yes, we are able to vouch for the safety of those fish with respect to the contamination from the spill.
Dr. LEHR, do you agree with that? Do you agree that the federal government is able to vouch unequivocally that the fish caught in state waters are safe to eat as well as federal waters?
Okay. I would say that the fish caught is meeting all the standards that were developed by FDA and NOAA.
And what about non-commercial fishing? Recreational fishing is a major tourism sector in the Gulf. Can we be sure that those fish are safe to eat as well? Mr. KRAEMER.
FDA isn't directly responsible for recreational catch, but I can tell you that and the states, again, exercise that control, except in federal waters where NOAA exercises that control. But the states have implemented closures for recreational catch that mirror the closures that they have for commercial catch. So the safety of the recreational catch should be at the same level as commercial.
Thank you, Mr. KRAEMER. Dr. Anastas, with regard to the use of dispersants, Dr. Suetoni of the Natural Resources Defense Council says in her testimony that, quote, it would be unwise to draw conclusions about the safety of this unprecedented application of chemical dispersants from 2 laboratory experiments and field observations. Do you agree or disagree with that statement?
I think it's important to follow the data.
Excuse me?
I think it's important to follow the data. And what that means is that we look at the data and what that data tells us, but never remain satisfied. That's why we have ongoing monitoring programs. That's why we will always continue to ask the tough questions. That's why we are looking to have an ongoing long-term research plan so we do understand not only the current situation, but the long-term effects.
Okay, thank you. Mr. KRAEMER, polyaromatic hydrocarbons, PAHs, are one of the most concerning compounds present in oil because of their significant health impacts. However, these compounds are also very quickly metabolized in aquatic species, particularly in certain types of fish. It is my understanding that polyaromatic hydrocarbons are often metabolized into products that are retained in the flesh and can be more toxic than the parent compounds. In the market surveillance, is the FDA examining the metabolites of PAHs in the analytical sampling tests?
It is my understanding that what we're looking for is specific PAHs and not any metabolites of those PAHs. So I think the short answer is no.
Dr. Seifert?
I think there's 2 points of clarification I'd like to add, Chairman Markey. To go back to your question on heavy metals, which I'd like to get to clarify on the metabolite issue, we have been engaging some experts in academia to discuss just this. I've had several conversations with Dr. Ed Overton at LSU about their experiences with PAHs and metabolites that may be derived from those, but we are not currently testing for those. But I do want to add that to date we haven't found any level. In fact, almost every test that we've conducted on the fish and shrimp that have been collected to date and other seafood has been completely negative, below our limit of detection for the PAHs themselves, if not very, very low levels, as Mr. KRAEMER stated, 1,000 times below what one would
Have you been looking at fish that are right now inside the oiled areas?
No.
No. I think that is important for people, and I would recommend to you that you do some testing there. I think it's important for the public to know that inside the oiled area you're also doing testing, because people will be concerned that there could be some migration outside of that oiled area subsequently, especially if the fish then move to areas where they're traditionally caught that might not be there in that area, and that might not be this month or next month or the month after, but some point in the future. I think it would be very helpful if you would do some of that testing as well, just so that we can see what happens in the most concentrated area as opposed to where you're now testing. And I think that's important information. I actually think it's important information going forward, long term. We should know what happens to those fish where the oil is most dense at this time. Doctor?
Just one more point of clarification on I think this point, which is very well taken, and your points on heavy metals. We are also engaging with NIH and other scientists to develop long-term toxicity studies. I think those are incredibly important in terms of looking at potential for accumulation of heavy metals and toxicities that may derive from that. And again, I would add that we do think that the surveillance through the Mussel Watch program is an incredibly important first line of defense, but that there are active discussions about long-term toxicity studies, and we will be engaging in these studies for years to come.
Again, I would think that it would be important to begin those studies right now by going to the most potentially toxic areas and finding the samples now that are then used as your baseline. And I think that that's long-term going to be something that a lot of people wished was there in significant quantities in order to match off about what is then found at the periphery. So I would recommend to you that you do that. And again, let me ask the question again, do you plan to test for metabolites?
I think this is part of our ongoing discussions with NIH. In fact, there's a meeting happening right now with several of the agencies and long-term toxicity studies, and the design of those is one of the points under discussion.
Okay, well, thank you. Mr. KRAEMER, there has been much criticism of the seafood sampling plan, particularly about the method of risk assessment. It is my understanding that the level of contamination with PAHs, which is considered safe, does not take into account vulnerable populations such as pregnant women and children. And this is because the assumptions made in the plan calculate safe levels based on an average adult male body weight of 176 pounds. Has the FDA produced guidelines to ensure that children and pregnant women are adequately protected from contaminants that may be present in seafood?
I think the short response to that is that we believe that the levels of concern that we established for the reopening protocol are quite conservative and will be sufficiently protective for all populations. But we also acknowledge that these are valuable comments, and we are committed to looking again at the calculation of the levels of concern to make any judgments about whether we need to modify the levels that we've established for the reopening. I would like to point out, though, that again, as we've mentioned before, the levels that we're finding in fish flesh are essentially at levels of that they would have been at before the spill. So whether or not the values would change, we're not seeing levels that should be of concern for children or pregnant women.
And I appreciate the conclusion which you've reached, but as you know, for 100 years, almost all medical research was done on the prototypical 176-pound male, and only in the 1990s, under pressure from the women's movement, that did independent research that dealt with the unique nature of women and children begin to be introduced. So the very fact that the classic 176-pound male is still used here is something that I think you should re-examine in terms of whether or not that is sufficient to deal with the more vulnerable population, which are women and children in this particular instance. The extrapolation of all of these lessons over to women and children, I think, is something that is probably now outdated, and this may be one of the last remaining models that continues to stay on the books as the exclusive means by which such a measurement is, in fact, made of the risk to human beings. Mr. KRAEMER, if an analytical test conducted by NOAA indicates that contaminated seafood has been found that was harvested from open waters, how does NOAA communicate this to FDA, and what is the feedback method to stop others from fishing in the same place?
Well, we have communications with NOAA at a number of levels. So we communicate at the senior leadership level. We communicate through the National Incident Command process, and we also communicate on multiple daily calls between all three agencies at the staff, scientific, and technical level. So any one of those routes could be used to move that information. Fortunately, we haven't had to deal with that information yet. But if it were to occur, we would immediately investigate, and that investigation would be to look at the analytical results, confirm that they in fact show that the product is what FDA would call adulterated, and if we found in fact that it did reach that level of concern, either we or the state would act through our authorities to remove that product from the market, and also to reevaluate the adequacy of the closure that's in place.
Okay, thank you. Dr. LEHR, last Friday, Admiral Allen issued a directive for a coordinated, integrated system of ocean monitoring involving federal, state, and academic monitoring efforts to detect remaining submerged oil in the Gulf. Can you tell us more about this effort and why this directive was necessary at this time? Was this coordination not occurring over the past 4 months?
coordination in terms of tracking the subsurface oil has been happening since the beginning of the spill. In fact, early on the spill, we went out and made arrangements with the experts who are experts in, for example, well blowouts from Clarkson University to provide us their information of how the oil would act. We also made arrangements with Syntef, which has a subsurface model that we could track the oil, and now we've brought in our own models that are tracking it as well, tied in with all the detailed sampling that's being done. Now, I think the directive is now, of course, other groups, independent and other agencies have been doing it, and the idea is to now bring them all together as a coordinated approach. I think that's a good idea. But
so are you saying that this is nothing more than a continuation of what was going on all along? And
I would say that,
I guess I would ask is, why was a new directive necessary if this was something that is nothing more than a continuing effort?
I think that that what the Admiral is stressing is that we're focusing now on the subsurface oil, with the surface problem being removed, and they can bring in extra resources to do that. Many of the folks at NOAA that I know of who were doing the surface trajectory have now been transferred to working on the subsurface trajectory collection. So I think it's a redirection as the problem has evolved, and leave it at that.
Thank you. What do we know about the dispersed oil and dispersant that is on the ocean floor? What species are affected there, and how does that impact the food chain? Dr. ANASTAS.
I think you ask an extremely important question. There are issues that we are looking to, in real time, to develop research plans in the immediate and the longer term to fully understand what the oil is doing. I do refer back to the opening statements about we are not detecting dispersants in any concentrations to the limits of our methods of detection. So we're not seeing those the presence of those substances.
So are you saying you are not seeing dispersants and oil collecting on the ocean floor at this time?
In the thousands of samples that have been run, we are not detecting dispersants, the dispersant constituents on the ocean floor at this time. We have not seen a hit of dispersants at this time. We have the one hit that was referred to in NOAA, the one hit that was referred to at EPA and EPA testing. But the question that you ask about the oil on the ocean floor, we've seen some reports in the media that have talked about the oil on the ocean floor. This is something that as we look to ensure we understand the long-term effects, that this is exactly one of the questions that we need to investigate and find out, either confirm or disprove the presence of this oil, and also to understand the impacts of this oil.
Okay, thank you. Why don't we do this? Why don't we hear from each one of you in reverse order of your opening testimony, so that you can tell us what it is that you want the American public to understand about the state of the Gulf of Mexico at this particular point in time. We will begin with you, Dr. ANASTAS.
Thank you very much. I think the single message that Administrator Jackson has sent is that we need to be vigilant on understanding what the nature of the problems are, the immediate term and the long term, and that monitoring is crucial, that this crisis is not over, that the monitoring will continue, the work will continue, the research will continue into the long term. And getting that understanding not only to inform our decisions, but to make sure that we get it to the American public as quickly as possible, is one of our primary goals in accomplishing our mission of protecting human health and the environment.
Okay, great. Thank you, Dr. ANASTAS, and thank you for your work on this issue. Mr. KRAEMER.
Thank you. The question that we're very often asked in FDA is, what should a consumer do to make sure that their next meal of Gulf seafood is safe? And the answer I like to give to that, and I'd like to respond here, is that they needn't do anything. That's FDA's job, and we take that job very seriously. We are confident that the program that FDA has put together, along with our colleagues in the federal and state governments, is sufficiently protective, and that they need not take any steps to protect themselves from the seafood. That it is essentially at the same level of safety as it was before the spill. Having said that, we recognize that this is an unprecedented event, and our looking at the long-term safety of this source of food is something that we can't overlook. And I think we've mentioned here a few ideas of things that we do need to look at into long-term studies, the development of methods that can detect contaminants that we presently can't detect, and we think those are positive steps to providing further assurance to the public.
Thank you, Mr. KRAEMER, very much. And Dr. LEHR.
Okay, thank you, Mr. Chairman. Before I get to my closing statement, I want to correct one thing. I'm a good scientist, but perhaps a bad impromptu speaker. And so one of the things that you brought up was to suggest that this calculator was not involving independent scientists. The independent scientists contributed to the development of the calculator, and independent scientists, very qualified scientists, will be the ones who are doing the reviewing of it. The field of oil spill science, I like to say, is so small that we could have a meeting in a ballroom and still have plenty of room to dance. And we've been able to tap many of the biggest names in that field for both the review and for the development. So I would like to stress that, particularly since there are other folks who this is their first big spill when they're coming in, and perhaps don't have the background in this area. Now, for my other comment, I would like to, as my colleagues have said, this is a continuing operation. The spill is far from over. We're beginning in a new phase, and NOAA and all the other agencies will be involved in this. And for those of us who are spill experts, we get paid for doing this. But what I would like to think, and that people don't give enough credit to, when we went to develop our tools, both in terms of the flow rate calculations and in terms of this budget calculations, we went out to many of the independent academics and other experts, and in many cases they were not being paid any compensation. I have not yet had a single instance where any of those folks have refused to work on any of the projects and the requests that we have done. So if there's a silver lining in the terrible event of the spill, it's the extent to which the American people are willing to volunteer their efforts at the most highest expertise level down to the fellows who are volunteering to come out and clean up the beaches, such tragedies do bring out the best in our country, and I think that that's something that should be more brought forward, perhaps.
Thank you, Dr. LEHR. And again, thank you and all of you for your work. The point that I was making earlier was that in terms of the study that was released last week, first you gave the answer, and now you are going to be showing your work, but in a peer-reviewed way. And that's the opposite of the way in which a study of that magnitude would be released. And all I am saying is that given the way that this has unfolded, that it's important that everyone, including independent scientists, who may not have participated in your creation of these models, can see the assumptions upon which they were based now, given the fact that the peer review is going on right now, but the science experiment in the Gulf of Mexico is occurring in real time, so that there can be a real capacity to have all questions asked and answered, not months from now, as part of a boring academic exercise sometime next year, but right now when concern is at its highest. So again, I restate my request to you that you provide that information to independent scientists who are not part of your study, so that there can be a fresh set of eyes and minds that are applied to it, because the consequences are great if you're wrong. If you're wrong, the consequences could be great. So let's just err on the side of safety. Let's have that information be given to the rest of the scientific community, given the way in which that record was put together. So we thank you, Dr. LEHR, and we thank, again, in no way do we want to say anything other than we thank you for the work which you've done thus far. It is in an exceedingly difficult working environment. It's unprecedented what has occurred in the Gulf of Mexico. We have this hearing principally because the public has a right to know that there should not be a 6-week period, a month-and-a-half period, where Congress has not been working on this issue, given the fact that it is our responsibility to make sure that the public interest in all aspects is protected. So we thank you, and we ask you perhaps to make yourself available to return again to answer additional questions, because this is something that obviously is going to affect the Gulf of Mexico for months and years to come. With the thanks of the committee, we appreciate your contribution.
Thank you, Mr. Chairman.
Thank you. Before we hear from our next set of witnesses, for the record, the subcommittee invited the Louisiana Department of Wildlife and Fisheries to participate in this hearing. The Louisiana Department of Wildlife and Fisheries makes the decisions regarding opening or closing of fisheries in state waters affected by the spill, and has been working in consultation with the FDA regarding opening and closing of fisheries. Although nobody from the department was able to attend, the Louisiana Department of Wildlife and Fisheries submitted a statement for the record, which I ask unanimous consent to move into the record at this time. Without objection, so ordered. I would also like to move into the record a statement from the Center for Science in the Public Interest. Without objection, so ordered. We will now move to hear from our witnesses, and we ask those witnesses to please move up to the witness table. Great, thank you.